Today I am going to make a video on the remaining reaction intermediates, that is nitrenes and arynes. Nitrenes are monocovalent nitrogen having a sextet of electrons, means 6 electrons. Same like octet, for forming a stable complete inert state we need octet of electrons, that is 8 electrons, but here we are deficient of 2 electrons. That is why it is called as sextet of electrons. Nitrene, it can be represented as like this and a bond pair here. Now this two combine to form a bond pair and these two are lone pairs. 1, 2, 3, 4, 5, 6. For this R, if I use a simple group like hydrogen, then it forms HN. That is, this is the simplest form of nitrene. This is called as imine. Okay, now this nitrene intermediate, same like carbenes. In my video 3, I have shown how carbenes are having different states. Same way, nitrenes also exhibit 2 states, that is singlet state and triplet state, with a very slight difference. Since it has got 6 electrons, I will show the diagrammatic representation. Nitrogen here, p orbitals, carbene, we have 2 sp2 orbitals forming 2 covalent bonds. In nitrene, we have this nitrene is sp2 hybridized. Now, this nitrene forms 1 covalent bond, that is, 1 sp2 orbital forms 1 covalent bond. The other p orbital, that is perpendicular to this nitrene, remains vacant, and these orbitals share pair of electrons. Now, same way, I'll draw the triplet state. Triplet state also, we have the nitrene, 1 covalent bond, you can see this, and the p orbitals, 2 of the p orbitals, let us assume it to be px and py, or py and pz. These 2 p orbitals contain unpaired electron. The other sp hybrid orbital contains 1 lone pair of electrons. This nitrogen is sp hybridized. Now, here in this singlet state, there are 2 lone pair of electrons. Since there are 2 lone pair of electrons, the internuclear repulsion is between these 2 orbitals is much more. More internuclear repulsion can be seen since there are 2 lone pair of electrons very near to each other. In this triplet state, it is sp hybridized and the lone pairs there is only 1 lone pair and the electrons are separately distributed 1 each in the p orbital. This minimizes the internuclear repulsion, which means there is less internuclear repulsion. Since the repulsions are less, this triplet state is more stable. And here it becomes less stable. This triplet nitrene behaves as though it is in ground state. Now, this whole figure, this singlet state and the triplet state, can be like this. Are shared pair, shared bond pair. These two can be shown lone pair here, and one lone pair here. This singlet state can be represented like this. The triplet state can be represented, this is the bond pair, nitrogen, these two, one lone pair and one electron, unpaired electron like this. Now let me show you the structure of arynes. Arynes, they are another important group of reaction intermediates. As the name suggests, it is a benzene. It is a kind of a benzene ring. Arynes come from arenes. Only Y is replaced. E is replaced by Y. So arenes, what was arenes? Arenes was benzene. Benzene rings are called as arenes. So let me put the double bonds. This is a benzene ring, but I'm talking about kinds. If it is a double bond, for a double bond, 1, 2, 3, 4, 1 hydrogen, 5, 1 hydrogen, 1 hydrogen in every place. In a triple bonded carbon, 1, 2, 3, 4. This